Eh, Sado, Erin. Uh, Good evening, everyone. I, Sanjana Chatterjee, on behalf of IISWBM Energy Management Department and AEE USA India chapter, want to convey our heartiest welcome. It's an honor for our department that you took time out of your busy schedule and joined us. And this webinar will take you through an immensely informative and motivating event today. And basically, we are here today to enrich our knowledge on the topic energy transition way towards sustainable future. So now I would request Ms. Piali Gupta ma'am, Assistant Professor Energy Management, IIS WBM Kolkata, to give the welcome address.
Thank you, Sanjana. Thank you very much. So, a very good evening to everyone. So, this is I will give you an introduction about WVM Energy Management Department and also EEUSA as WVM Kolkata chapter. So, about AEE USA as WBM Kolkata chapter, this chapter is first chapter of Association of Energy Engineers in India, which is inaugurated in February 21, 2003. So the senior managers in energy-intensive industries in the region to share the US counterpart on state-of-the-art technologies and practices in energy management. The AEE USA ISWBM chapter India, securing the international awards during last 18 years. So the chapter has been honored with many various awards, like in different categories, like Best Chapter Website, Best Today Chapter, Best Services, Best Chapter Newsletter, etc. The chapter has also received Best Overall Chapter Performance Award in the year 2005, 2009, 2010, 2014, 2015, 2018, and Best Community Services Award year 2021. So, and moving to our department is a team management department. So ISWBM, you know that ISWBM is a pioneer in providing MBA in energy management since 1993, and it's affiliated by University of Calcutta. So this energy management department is also recognized as Association of Energy Engineers AEE USA India chapter since this 2004. So every year, 90 to 95% students of energy students get placed in different reputed MSCs, consulting firms, renewable energy companies, market research firms, energy audit, then and engineering companies, including Ernst & Young, then Ernst & Young Private Limited, then Price Coopers, Manikaran Power Limited, Adani Green Power Limited, then Enkin International, Post Climate India Private, etc. So there are many more. Get the more details in our website also. The placement assistance also provided by the institute. So many of our alumni are the highest position in the organizations and many entrepreneurs. Energy management students every year they receive award and also scholarship from AE USA as a student scholarship. So with this short description of our AEE USA Kolkata chapter and also our energy management department, I would like to move to our main section of today's talk, just energy transition that will be delivered by Dr. Raj Banerjee from Schlumberger, USA. So welcome you, sir, and it's been really honored for us that you have time that are coming from your place and give a lecture to our students and different participants from the India and also abroad and who are either our energy management students or AEE chapter members and also different from the different colleges from India and also some participants are also. So welcome you all once again and moving to Sanjana. Sanjana, please give a short description of to the speaker and then move to our speaker.
Yes, ma'am. Thank you, ma'am, for your valuable words. And now I would like to introduce our today's speaker, Dr. Raj Banerjee. He is an advisor in Schlumberger at the world's leading. Okay, sorry. So the world's leading oilfield services company. He is currently based in Houston, USA, where he provides the technical advice on software and workflow related to oil and gas production. His areas of expertise include reservoir engineering, production engineering, and production operations, including digital oil fields. With recent focus in energy transition from fossil-based system to renewable energy, he is also paying attention to these exciting new areas. Now he has done a PhD degree in applied mathematics from Imperial College, a master's degree in petroleum engineering from the University of Tulsa, USA, and bachelor's degree in petroleum engineering from IIT ISM Dhanbad. He has 15 US patents and numerous international publications also. Now I would request Dr. Raj sir to carry forward the program.
Sorry, can you hear me?
Yes, sir. Yes, sir. You're audible.
Yeah, can you let me start my video, please? And yeah, if you let me start the video and let me share my screen. Okay, the video is started.
Yes,
Now,
yes, you're visible.
Yeah, I think you can. Can you see my screen?
Yes, sir.
Okay, this is the main screen. And I guess you can hear me properly.
Yes, sir.
Okay.
Yeah.
So, yeah, good afternoon, all of you. And thank you so much for taking time to attend this talk. And this is something really I'm passionate about, so I'm happy that there's three of you are present. This is Saturday afternoon, so you should be partying somewhere. Instead that you are listening to the talk. So this really shows, your institute, how committed you are. Uh, and Sanjana, thanks for introducing me and for arranging the talk. The topic is transition, and I'll go and explain what I mean by that. Because there's a lot of discussions, talk, debates on this area, and why is the sustainable future important for us? Do you see a mark, a red mark in the screen? I don't know. It's just me. Okay, so let me introduce a little bit about my company. So it is Schlumberger. So I know it's a bit difficult to pronounce name. It's because the origins were in France, so it's more of French name. So we are the world's leading oilfield service provider, and we consider ourselves a technology innovator. So the way describe us is that we create amazing technology that unlocks access to energy for the benefit of all. So it's, even though most of the work, we have done in oil and gas, we are moving to the sustainable energy, new energy, looking forward, going forward. So our market cap, just as an information, it is 54 billion US dollars, so which is quite a bit. And we are spread over, 120 countries in the world. So most of the major countries have a presence. We started in Paris, but now our head office is in Houston, where I'm based. We have also major offices in London, in Netherlands, and of course in India. We started in 1933, so years after we, in 1926, the company came into being, and 1933 we were there in India, in Assam, involved with the drilling operations and with the well in Assam. So the company itself is very multinational. We have 160 nationalities represented in our company. Having said this, now our company there are three main areas of focus. So one is the core services and equipment. So this is what I was talking about. This is all related to oil. So this core services, we talk about the pumps, we talk about measurements. So anything, labs, anything that involves addition of technology. So we ourselves, we are not oil producers. We help companies like ONGC, Oil India, BP, Shell, Exxon to find oil and produce oil. But we actually give them the state-of-the-art technology to do that. So that is one division. The other focus is digital and integration. So which means we have moved on to the digital world, and all the software and connectivity and sensors and everything that is actually done by this digital and integration. So this is the section, this is the division I am in, and basically I'm a petroleum engineer, as Sanjana mentioned, but with deep interest in software. The third new focus is on new energy. So this is what we'll talk about today. And being part of the digital world, I get involved into the core services as well as new energy. So we'll talk about new energy and transition to the new energy in today's talk. Moving on to the next slide. So here on the right-hand side, I just wanted to set the stage for our talk. You see the background, these are the hot pumps. In my field is these are just like hand pumps. These pumps, and they are used to pump oil from deep underground the Earth's surface. Well could be, say, around 2 kilometers, deep, or even if you really consider extreme cases, it will be around 10 kilometers. So these are the pumps, that are used among other pumps, but these are, positive displacement pumps, which are used to lift the oil. So it's quite a difficult task, So I'll go and explain a little bit of that. So from there, you see in the foreground, you have all these solar panels. So moving from one source of energy to the other source of energy, the solar energy, or any other type of energy is really a big change. It is not only a change in the energy type of energy, but it's also a change in the philosophy. How we work, how we do it, the process, and so on. So that is what we'll talk about today. I'll introduce the subject. I'll talk a little bit about the petroleum age and why oil and gas has become so important. And then, obviously, because everything is not good with oil and gas. So what's wrong? And how do we take care of it? So I'll talk a little bit about CCUS. And then how we move to the new energy. So what our company, especially Schlumberger, is doing in the area of new energy. Then finally, with some concluding remarks. Okay, so let's look at the type of energy that is used in the world today. So most of the most popular, obviously, is oil, which is 31% of the total consumption is oil. And the next is coal, which is also very important. So coal is not that important in the US, but in India and China, coal is extremely important, still continues to be important. And you have natural gas. So look at it this way, if you can talk about renewable, it's only 6%. Hydroelectricity, it is 7%. So nuclear energy, it is 4%. So you might be thinking that, okay, these all renewable hydroelectricity, they're hardly there. There's only 6 and 7% and 4%. It means nothing. So, but look at it this way, 31% or 25%, they're big numbers, but in the journey it took to get there, and how fast this whole thing can flip. That is what I want you to appreciate today. Just because oil and gas is occupying a major place, it may not be this continuing, and there are good reasons for that. Okay, so one of the reasons, why oil and gas, even so versatile and so important in today's economy, is not good, because when you actually burn fossil fuels, you produce CO2. Okay, so which is global warming through greenhouse effect, and then there are other things like pollutions and so on. So basically, it is really bad for us. It has given a lot of development to the world, but then a time has come that we have to realize how do we take care of our future. So for that, so that is what energy transition is about. So energy transition refers to the shift from fossil-based systems, that is natural gas, oil, and coal, to renewable and sustainable energy sources. So it's basically, it is our survival. Even though oil and gas has given a lot of development to the humanity, it is the survival of humanity that's actually making us think and move from fossil-based fuel to sustainable and renewable energy sources. Now, this is very significant. I mean, change is not something that can be done overnight. There is a conscious effort to do it, and it is not just technology. It is not, it's not like solving a question and making a few machines that will make the change. So there's a change in scale. Things which are not to scale today, they have to be made to scale. There's a question of economics. There's a question of end user behavior change. So the user, consumer of energy also has to realize and see the benefit of changing. So it is not just an idea of social change. It is also economic. Actually, the user has to be benefited in a way that it is, better using renewable energy than using oil and gas. And of course, finally, politics comes into play. So that is also important. So having said this, let's go and talk a little bit about the petroleum age. So it's not that oil has been there with us forever. You really look at in 1859, which is not very many years ago, it's less than 200 years ago, you had the first oil well was drilled in Pennsylvania. So then there was, it was not, oil was hardly anything, as back in 1859. Coal, commercial coal was 100 years before that. So these fuels have not been there for a long time. And if you look at it this way, the cars, which you see all around these days, the first car was in 1886. So again, the picture car up over there. So it's nothing like the cars you see today. It's nothing like the Mercedes and the Jaguars which you see today. Even if you look at air travel, which is possible because of oil, the first airplane in 1903 was nothing like, the jumbo jets, Emirates and the British Airways you see flying around these days. So things have been moving very fast in the last 160 years or, 200 years. And oil has become, extremely important. So this petroleum age has given rise to a lot of developments in mankind, and but it has come through a lot of pain as well. The rapid development has not been automatic, and if you really look at, typically when you are actually talking about oil and gas, the background, why people are why it is so expensive and so difficult to do this type of work is typical project in oil and gas field. You have seen, you have oil in Bombay offshore. How does it work? How does it happen? It goes in a project typically for getting oil and gas is divided into various stages. So a project can go on for years. An oil field can produce 40, 50, 80, 100 years. The Digboy oil field in Assam, it has been there since the 1870s. So it's a long-term plan. And typically many of these projects could be around 40, 50 billion dollars throughout the life of the project. So you look at how do we search for oil? So oil, as you know, is in underground oil reservoirs or underground gas reservoirs, gas. So these reservoirs are nothing. These are not lakes or whatever. These are in rocks underground. 2 kilometers, 3 kilometers below the Earth's surface. They are porous rocks. And then you have the fluid or the oil in the rock. So how do you know where it is? So then that is a long story. So basically what you do is you do geophysical prospecting. That is just like doing ultrasound. So you send signals down to the earth and you basically find out what is the nature of the container where the oil is underground. So this is actually the exploration phase or searching for oil, phase. So once you have certain indication, you can never be sure there is oil until you drill, but once you know that there's a little bit of oil, then next comes the appraisal phase where you determine how much oil is there. You drill wells. So these are deep wells, as I said. They go, it could be as deep as 2 kilometers down in the earth, and you basically try to get to those oil, and how much oil is there. You try to find. Then and it could be onshore, it could be in the sea. And these are massive rigs you take, particularly if it's offshore, you take to the offshore and you drill these wells. So once the well is drilled, then you need to take out the oil. So it may come out by itself, but it might need help. So you could have pumps, you could have rod pumps as you see in the picture there, or you would be using something like electrical pumps. So you have gone through the whole process of and it's not one well, you are drilling hundreds of wells. So and then you are producing the oil from underground, and then it is taken to refineries where it's cleared, cleaned, and different fractions are separated, and then it goes to then you sell it, and it goes to your petrol stations, or you make petrochemicals out of it. Anything you see, so many things you see around you will be made of oil, including textiles and you name it, plastics, or so it's not just supplying energy, but supplying these other things as well. And then finally, when you have taken out enough oil, and it is not economic anymore, so you have to think about the environment. So you have to basically plug the well, stop the production, see that there isn't any contamination of the environment, and then it goes, the field has completed its life, and you abandon. So you see, it's a very difficult process, and very tough task to actually go look for oil and produce it. So if there was alternate source, you look up and you see the sun, and you could extract energy from the sun, then obviously you wouldn't do all these things. So for us, it makes sense, not only environment-wise, but economics-wise also. If we have better means of alternate sources, renewable sources, we would do much better. So yes, so this is just a picture of the oil fields of the world. So the red are the gas fields, giant gas fields, and the green are oil fields. And it's all over the world. You spread all over the world. You see in US, there are quite a bit. In India, you have in Assam, you have in Gujarat or Bombay offshore. It's there. In Saudi, there's quite a bit, as you can see. So it's all over the world. And the question today is, with such widespread use of oil and gas, how do we move to something else which is less dangerous to the environment? So that brings us to the question of, you cannot change overnight. So what do you do in the interim? So you are producing oil like anything, as you saw in the map everywhere. You're using this oil. You have, transportation, power generation, everywhere you're burning fuel. And that is actually creating a lot of CO2, which is actually having effect on the greenhouse gases, which is having effect on climate change. So there is something in the interim which you can do, which is carbon capture, utilization, and storage. So basically, you capture the CO2 from either it could be from atmosphere, which is bit difficult to do, or it could be directly from the flue gases which are produced when you're burning the fluid in power plants and so on. So you capture and you remove that carbon CO2, and then you can utilize it. So to utilize it, you can either convert it into something useful like fertilizer, or basically you inject the CO2 underground. So either you can store it permanently, or you can use it for something known as EOR, which I'll explain in a bit. So, just repeating what I said. So oil and gas is pretty versatile, but it has a layer of this production of CO2, combustion of which actually produces CO2, which is really bad for us. And this CO2, how we get rid of it. Now, as far as I'm concerned, for me, I work in the, a little bit in the area of storage and enhanced oil recovery. And I'll tell what those are. So when you have the CO2 coming in quantity, so one of the things you can do to permanently get rid of it is actually, again, drill a well and you store it in rocks underground. So send it back to where it came from, basically. So this could be old oil reservoirs or gas reservoirs, or it could be even aquifers, water reservoirs down underground. So again, so basically when you are doing those, storing and containing the whole thing, we have to do a lot of studies, so it is not, blindly drilling wells, the neighborhood well and storing it. So you have to really study how much CO2 can be stored, the injectivity of the wells which are using to store the CO2. And also, how much of it you can store. So it's a containment, keep on injecting, it might come out from some cracks somewhere in the reservoir. So all these studies, they are done, one of the tools used is reservoir simulation. Means we use computer programs which actually models the flow of CO2 underground. And this is the same principle we use for studying oil and gas production. So you see, many of the technologies which are there, and I'll show, as we speak, I'll show you more examples, which are used in oil and gas production, can be repurposed for, in this case, for CO2 storage. Drilling of the wells. So drilling is there in oil and gas. Drilling is also there here for storing the CO2, or studying the fluid flow, studying the rocks. Same thing, basically, you do for oil and gas, and now you are doing to, take care of the effects of oil and gas, which is for CO2 injection. So these things, it's not that they are new technology, they are reuse of old technology, repurposing old technology. So how do we get rid of the CO2? So one thing was to store it somewhere permanently. The other thing is, which is not as clean, is that, we know oil is there, we have to recover oil. So how you can efficiently recover oil? So one of the things you could do is you actually inject the CO2 down to the earth. And what happens is CO2 mixes with the oil and it makes it more, it pushes the oil out, and also it makes it more mobile, because it is the viscosity of the oil. I mean, how smoothly the oil can flow, it improves that. So this thing is not really getting rid of the problem, it is just reducing the problem. You're still producing, but the CO2 is helping you to produce oil more efficiently. So yeah, so greenhouse gases will there, the CO2 will come out, not all of it, but some of it. And then obviously you will burn the oil that you're producing. But here in this case, at least, you're mitigating the effects of CO2 by re-injecting it back. So this is, about storage and about EOR, which is basically part of the carbon sequestration process. This area, I'm just showing you in few slides, but this is an upcoming area. And there's a lot of interest globally on this area. And many of the oil companies, or most of the oil companies, while they're producing oil, they are also investigating how they can, do this CCUS efficiently. Almost every oil company is there, involved in that. So yes, so we talked about how important oil is, and I'm coming from the world of oil and gas, but even there are the arguments for coal as well. So all the fossil fuels, they're very important, as we said, but the importance of actually moving it out also from these are extremely important as well. So you see, there's a whole bunch of technologies which are there. And obviously, my intention is not to cover them all. So, but there are a few things, so there is a possibility, there's a huge future. It is not that if we don't have oil and gas, we are stuck. It's not that way. So we have a choice, and that is good. But you see, this change is coming. It is, if you think that, okay, nothing will change, that is not true. See, when I was a kid, and I'm talking about 1980s, that time, most of the railways, you had steam engines pulling the railway cars. And my dad used to be an engineer with the railways. So his job was to make sure that the steam engines are working fine. In 70s, in no time, those days, Indian Railways decided to switch over from coal, which was relatively much more dirtier than oil, to diesel engines, or diesel or electric engines. So people had to be retrained. That time, my dad was, very studying how to, it was his middle of his career, changing from, coal engines to diesel engines. Transition happened. So that was the early case of transition to something very dirty to something which is less dirty. So today, if I look around my neighborhood, you see, everybody, so these days, almost everybody has cars. And if I look in my neighborhood, I see that many people have Tesla, the electric cars. So I would never think that you would have cars, running on electricity, on battery. So today that is happening. The change is happening. So really, it's amazing, and you'll see in the next few years, how this change to more renewable energy takes place. So for us, Schlumberger, so we have this, as I said, we have this new energy division, and for us, right now we are focusing on three things: geothermal, geoenergy, and hydrogen. This is in addition to CCUS. So I'll very quickly explain what we are doing in this area, and then how it is adding to the energy mix, and how we are, helping us to move forward to the new future. So the first is geoenergy, and so geoenergy essentially is making use of the energy underground. So this is not very deep. You see the temperature of the rocks, say 500 feet or 600 feet below the building, is different from the temperature at the surface. So the idea is to take advantage of this difference. So basically, you see, in summer, outside, the surface is very, very hot, and this 600 feet below the surface, it is underground. It is relatively cooler. So basically, how can we connect these two temperature differences to generate energy and take care of, for example, it could be just taking care of the heating and the cooling needs of the building. So this is, and this is a major consumption, So in the cities, so 70% of the energy consumed by these big buildings, particularly in Europe and America, that goes on for heating and cooling. Maybe not that much heating in India, but there's a lot more cooling in India. So yes. So, and you have a store of energy just very shallow under the earth, which actually is continuous and renewable. So there's a fantastic source of energy over here, and we are looking at it. So we have a company, a subsidiary. Schlumberger has a subsidiary called Celsius, which is in Paris, in France. And this is how it works. So basically what you have is a heat pump, and you have these wells. Again, this is reuse of technology. So these are shallow wells, 600 feet wells, and we have drilled wells, as I said, tens of kilometers. So drilling a 600 feet well is nothing. So you have multiple wells drilled under the building. See in the picture. And then these wells are, act as a energy exchanger. So the fluid is there. So it takes in summer, it takes the heat away and puts that in the ground, say around 600 feet below the ground. And then it makes the fluid cooler, and the cool fluid comes back. And then there is the heat pump, which allows this heat exchange, and the building becomes cooler. And obviously you have digital controls to control all that. So it's not human being doing it, it's digitally controlled. So in the winter mode, the reverse happens. So you have the fluid going underground and getting heated up because it's hotter now than the outside winter temperatures. And then it comes, and again the heat exchanger is there, and so the cycle goes on, in summer mode and in winter mode. And this is extremely, important in the energy equation. So you take care of a lot of the energy requirements for heating and cooling, and which if you had used, oil or electricity generated by oil, that would be resulting in a lot of CO2 coming out. So in this case, yeah, it's pretty clean and unending supply of energy. So this is one. The second one is geothermal. Again, we are focused, so geothermal is very similar to oil and gas, but here the difference is instead of drilling for oil, what you're doing is you're drilling for hot water. So it is near areas where you have volcanic activities, or even, even extinct volcanoes are fine. So you are drilling and to get hot water out, and this hot water is under pressure. So when it comes out, it is steam, or it can be flashed into water and steam, and you are just using the steam to, work the turbine. So there's a steam turbine, and that steam turbine generates electricity. So this is a very efficient process in the way that you're using hot water from the ground. It could be volcanic areas, or it could be even stable areas like under oil and gas reservoirs. So you could repurpose the same wells which you use for producing oil now for a more clean energy, like you're drilling the wells a little more deeper, and you're getting to hot water zone, and you are actually producing steam. Again, just like oil and gas, this is multidisciplinary approach. So you have to do the exploration, the drilling, the resource modeling, financial modeling, operation, so all these things are there. So yeah, so this is one thing our company has been doing for quite some time now. And one of the projects, very quickly, really I'm running out of time. So very quickly, one of the projects we are doing is in Indonesia. There's a major project we are doing. And Indonesia has a lot of potential because it is near to, huge number of volcanoes. And, so basically there is massive amount of geothermal energy which is there. And not only Indonesia, even actually, thinking about it in India also, there's a lot of potential along the Himalayas. And also in Andaman Nicobar Island, there's a lot of presence of geothermal energy. So we go through a process of project development. We do the exploration and the feasibility studies, and then we go and do the development drilling for those wells, and then we set up the plant, and the hot water comes out, and separate in steam and produce electricity. And then obviously when you set up a plant like that, with hot water, there's a lot of surveillance, maintenance, more drilling more wells and so on. So there's a whole process that goes on into producing this hot water or steam. So this is the geothermal part. And we are actually quite deep into it. I mean, traditionally also we have been working for quite some time in this area. The other area which is really coming up these days is hydrogen. And we realize that this has a lot of potential, because when you burn hydrogen, there's no CO2. It is just water that is produced. So there's there's hardly any emission. If you're burning hydrogen. But not only burning hydrogen, you can use also another process known as fuel cells. And I'll talk a little bit about fuel cells. So fuel cells can also be used to produce electricity from hydrogen. So basically here you see there is, I could have on the right hand side, you see this is a typical chart of how things are done for hydrogen for us. We are our job is to create these fuel cells. This is and how it works. So you could have solar energy or wind energy which supplies electricity to your home here. But also this extra electricity we have when in the daytime or when wind is blowing, we can use it to electrolyze water, that is to separate water into oxygen and hydrogen. We can store the hydrogen, as you see over here, in some storage tank. And this can be stored also underground. You could drill a well and you could store it, just like you store CO2. So you could do that as well. So, and then when the need comes, you just use that stored hydrogen, and then we have this electrolyzer now becomes a fuel cell. And what you get is electricity, and the electricity is fed in. So you see a whole cycle with different renewable energy, wind, solar, working together to actually produce clean energy. And this is amazing. I mean, just oil and gas is replaced by all these things coming together, giving a very efficient cycle. So what are we using? How are we doing this thing? So we have a company called Genvia, which is based in France. And the way we do it is through this solid oxide technology. It is highly efficient, and it is obviously very cheap to do these days. And when it's commercially made, people will actually want to move to this type of technology rather than sticking to oil and gas. Oil and gas spending billions to drill wells in places. Oil won't be necessary anymore. You could have hydrogen, you could have solar, and all these things, which relatively will become much more cheaper. So yeah, and it makes the whole thing versatile. So this is about hydrogen again. So there are other energy sources which I will not talk today, but there's one thing I wanted to bring to you. So we are looking at all these technologies, but behind these technologies, there is something which is making things more efficient, and that is digital. So it's computers. So these days, basically you can see the hand of computer everywhere, whether it be oil and gas or whether it be renewable. To make the whole thing efficient, these days you can see picture on the left hand side. This is an oil field, but it could be hydrogen storage area, or it could be geothermal. So you have all this equipment, and we are able to connect all these things through IoT or Internet of Things. So we connect these things, and then send all the information. Massive information is generated in this areas where you're actually producing the energy, and then you send it to the edge. So edge is at the edge of the internet, means here you can do some localized computing. For example, you are producing, this is working. So how the pump is behaving, that can be automatically monitored, and surveillance can be going on in real time to correct if the pump is misbehaving in any way. So that all this feedback loop happens in the edge. And of course, all the data is then transferred to cloud, and cloud, you're aware, something like AWS or Google Cloud or Azure, so it goes to the cloud. And you have systems like this all over the world. So you have big data, and all the bigger insights which you get from this data that is generated to increase efficiency is then again done in the cloud. So you have multiple, you have IoTs, you have edge, you have cloud, big data. So these things puts together a very efficient operations of the systems which we see. So, and this is extremely important, these days, understand the sweeping effect of digital and connectivity. And it is possible today because, almost every person I know knows programming these days. Even when I was a kid, that time do programming using Fortran, but now it has become so easy, so I can use Python, I can use the massive amount of libraries which are available, used by Python, just one example. And you could use machine learning, on top of Python, using scikit-learn libraries or using TensorFlow libraries from Google. So all these things are available, and most of the time it's available free for people to use it and then generate solutions to make all these processes more efficient. So yes, I think I'm running out of time now. So, but these questions are really to provoke some thoughts. So my whole idea was think the possibility, and it's a huge. So the future is bright, and all you have to do is you see and innovate. That is so nothing. There is nothing out of bounds. It is not that we have been doing oil and gas for centuries. Doesn't mean that it will be there. It will change, and it can change only with us enabling change. So that is, so there's nothing to fear other than not changing. So if I may say. So concluding, fossil fuels are very versatile. We know that, but while they are very versatile, they produce greenhouse gases, and they are not renewable. Also, oil will run out. It may not be there. It will run out soon. So we have to do something to save the world. So what is happening is the world is transitioning from fossil fuel, and we can see that change happening, at various speeds in various places. India also, they've taken a decision actually to move to renewables, very seriously. So India extremely seriously, like other countries, like any other countries. And the other point I want you to take away is the oil and gas companies are also playing a leading role. So don't think that oil and gas companies don't want change. They want change. And the reason for this is that if we can produce oil and gas, which is pretty difficult, as I showed in the presentation, there's nothing that stops us from making money producing energy from sun. Which is sitting right there. You open your window, you can see the sun. There's no drilling involved. There is no exploration involved. We know that the sun is out there. When sunrise happens, when sun sets, so hydrogen and all these things. I think, they're much easier problem to solve and will give us to a much better future. Thank you. So, and thank you for giving me the opportunity. And obviously, I hope you'll, be passionate about climate change. And the thing I wanted to point out is that to basically make this change, you have to be trained. You have to train yourself. So you have to basically realize that the world is changing, so you have to change. So to do this thing, you have to maybe enroll in classes which are more forward-looking for energy transition, energy mix. So it is important to study about energy, and I'm sure your university has a lot of excellent courses. Actually, the other day I was looking at your website, and you have some very good programs on energy management. So probably you could enroll there, or you could enroll in many of the other universities of the world. Like in the US, UK, or anywhere else. If you're liking. So yes, so basically, I'm hoping that you look at energy in a different way. Thank you very much. If there's any questions, I'll be happy to answer.
Thank you so much, sir, for your valuable words and like enriching us with knowledge. So, sir, we would like to start our question answer session. So, the first question is by Shivli Mukherjee, that is, CO2 injection is harmful to reduce the soil organic pool and affect the soil structure, soil fertility, and productivity also. So, what can we do to like solve that problem?
Yeah, so CO2, it depends on, that is why it is very important to actually understand where you are injecting the CO2. So if you are injecting the CO2, very shallow, then it will, have adverse effect. So what we do is when we actually injecting CO2, we choose aquifers or we choose abandoned oil and gas fields, which are pretty deep. And then we study the containment. So when you're getting it is contained there. So if it starts leaking and it is coming out to the surface, then again you are back to the square one, isn't it? So basically to study the injectivity, the containment, and to understand how much you can store and where to store, this requires considerable study. And if you do it correctly, the gas is contained. If not, then you can have dangers, as you mentioned. So you shouldn't go to the soil where you are actually planting and plants. I don't know if I answered correctly.
The question is like, how did the COVID-19 crisis
Sorry, can you repeat the question, please? Hello?
position?
Can you repeat? I couldn't hear. Maybe I'm getting cut out.
Yes, sir. Yes, sir. Like so the question is how COVID-19 crisis impact the energy transition, and it's by Shom Shubhra.
To me, obviously COVID is not good. So a lot of people died. There was a lot of misfortune and all that. But also, COVID allows encourage us to think out of the box. So, for example, using this technology. Earlier, if you had to do a meeting, you would have to go and sit down in a room and get together and talk. And now, even today, we're doing these Zoom conferences and meetings, and I don't need to go to office. So we are realizing that just traveling and doing things the way we used to do that may not be the only way. So essentially, it has opened our minds, and also it has actually made us think that conserving energy is also very useful. I'm not driving that much as I used to do before COVID. So I'm not burning fuel randomly like I used to do before. So these things, but it is having an effect.
Okay, sir. The next question is by Dr. B.K. Chaudhary, sir. He is like, from the school days, that is the last 3 to 4 decades, I'm hearing that gas is going to be extinct in 3 to 4 decades. It seems there is less new exploration. In your opinion, what may be the unrealistic time available to us to switch over to alternate? Also, some research says that we have already crossed the point of no return. Global warming cannot be controlled anymore. What is your opinion? Should we also control the emission of methane, which is 33 times global warming potential than carbon dioxide?
Yes. So last question first. I'm not an expert on global warming, but what I understand from that point of view, that yeah, methane and CO2 both are extremely important, and how we can reduce the emission. The first question is, I'm not too worried about us running out of oil. Okay? Because when we were thinking that we'll run out of oil, then came this unconventional oil, which is oil in shale, and uh, so we are nowhere near running out. For shale, all you do is you drill horizontal wells and you create fractures in the well. It is a very dirty process. So don't worry. But the thing is, once you do it, you can produce a lot of oil from places where you never thought you could produce it. And so much so, like 50% of the production in United States is from unconventional oil. In India, you could easily become, self-sufficient if you start, change your focus. Not change, if you extend your focus from conventional oil, which is mostly that is what is there in India, to unconventional, like coal seam gas, coal bed methane, that is, or even shales, which would be plentiful in India. So, but the thing is not us running out of oil. I think the issue is we have to realize that the danger CO2 produces for for climate change. And are we too late? I don't know. But what we should do is we should stop as soon as possible producing this CO2.
Okay, sir. Thank you. And sir, the next question is 100% renewable energy transition possible with current technology and how it will benefit the world? And it's by Torpan Ghosh.
See, I think we are not, technology is evolving. Technology will evolve. If there is a need, people will, every day we are innovating, we are finding new things, new technology. So I think here the challenge is more, if I can put it that way, it is the whole system. It is actually, making it scalable. Even if you have the technology, how to make the technology scalable. Or, how do you manage the politics of, different interests which are around, various things, so that's one major thing. And then the thing is economics. So I think economics plays a very important role. So people are not going to change because you tell them that okay, it is cleaner to use something else. People will change if they find it is more profitable for them to move to something else. And I think the way things are moving, this new energy, coal, the renewables are becoming more and more economic. And when it becomes economic, change will happen. And what I am seeing is things are becoming economic, and that is why changes happen.
Okay, sir. So the next question is, why has the concept of petro plants not been incorporated on a mass scale, and why are we not taking to their implementations to supplement the limited supply of petroleum? And it's
Sorry,
by Abhishek Maiti.
can you repeat it again?
Why has the concept of petro plants not been incorporated on a mass scale, and why are we not taking to their implementation to supplement the limited supply of petroleum?
So again, I don't know. Maybe it is economics of scale, and petroleum is not really limited in supply. So there is a supply. I think it's not. I'm not worried about the supply of of petroleum. You see the rise in oil price. That has to do with how the cartels are controlling the oil production. So There's a lot of oil around. The question is whether you should, for environment, whether you should produce it.
So, sir, the next question is, in case of renewable energy, we can say it is still not clean as it is thought, because a lot of materials used to like harness sun or wind energy still, oil or petroleum based like epoxy or resin or carbon footprint not so good. Span of good has good lifespan of these materials are not so long. So we have waste problem in this. So being an Indian, should we go for hydrogen economy? So what is the suggestion in this? It's by Soumya Sahu.
Yeah, this is a very good question. So basically, when I was talking about this hydrogen, you see, I could create the hydrogen from electrolysis. Okay, so I could use electricity to break the water and then have hydrogen. So this is typically called green hydrogen. But I could have also created electricity from burning oil and then use that electricity to do the electricity. So that is typically that is known as gray hydrogen. So depending on whether you are using renewable or not, you have different what colors of hydrogen. You use nuclear to actually get the do the electrolysis, and you have what is called blue hydrogen. So all this so this is stepwise improvement. So there is no black and white answer. You could have two plants, one using green hydrogen and another using gray hydrogen. There's different levels of evolution. So definitely you should look at hydrogen, but again, your source of energy in getting that hydrogen is also important. So you have to make that change happen from gray hydrogen to green hydrogen.
Okay, sir. So the next question is, what is the success rate of carbon capture? How cost of carbon capture is accounted under?
Sanjana, you got cut out. Can you?
Yeah. Repeat it, Sanjana.
Yes, sir. Like, what is the success rate of carbon capture? How cost of carbon capture is accounted under which cost head? And it's under Vimuri.
Okay, so this part, the costing part of it, I do not know. That is, there are people, it is a specialist discipline. Every company have their, accountants who are actually, doing the carbon accounting. So that part I'm not sure I cannot answer. But the other part of the question was what? Come again? Can you?
How cost of carbon capture is accounted? That's the next.
Yeah, so that the carbon accounting is a specialist branch, So I do not know much on the topic. So what I know is the technology part. And if you really look at carbon capture, there are two things which are there. Typically the processes are, there could be various, there are multiple processes like absorption. So you basically absorb the carbon and then you separate it and then you transfer it to wherever you store it. Now, having said that, there are cases, say you are actually capturing it, from flue gas. So in power plant or in cement kilns, that is relatively easier to do, and that we know how to do it well, and we can, the technology is there. The other part is how do you take the carbon from the atmosphere? Like there is so much of this, cars and everything in Calcutta. Kolkata? How do you capture all that? So that there is technology, but it's less developed. So the challenge is, not so much picking up the carbon from flue gas, but picking up the carbon from the atmosphere. That is, people are working on that. So that is something which we are looking at. I mean, you might have other experiences, I don't know. I mean, but getting the carbon out of the atmosphere is not trivial.
Okay, sir. Thank you so much, sir, for such an amazing session, and thank you for clearing all the doubts which we were having for a long time in our minds. And now I would like to request Dr. Binay Kumar Chaudhary, sir, Professor of Energy Department, to give the concluding remarks and the vote of thanks.
Thank you, Sanjana.
Yes, sir. Yes, you are audible.
At the outset, I would like to thank our revered speaker, Dr. Raj Banerjee of the advisor of Schlumberger USA for the very lucid representation of his transition from the very common thoughts of energy to the most modern techniques, technologies, and the practice that has been made. So we are extremely thankful to you for this mind-boggling presentation and discussions at the end that clearly reflects two things, sir, that people are getting more and more aware about energy, and you have satisfied today our desire of knowledge. Thank you so much for sparing your valuable time and adjusting to our need that early hours of your valuable hour, which definitely your most precious hours you have devoted to this service of the world, maybe from one part of the world to the other part. And I am also very happy to see that the participants are also global, though you are right that ISWM is a pioneer institute in India, and we are also pioneer in terms of introducing the energy management program, which is gaining more and more interest in this field, and that jobs and prospects also reflects clearly that the opportunity is increasing in this area. And we are going to have the 30th batch to take class. The admission process is on, and 30th batch will start in July. And we see here that this nice program being organized by the Association of Energy Engineers Students Chapter and the Professional Chapter jointly. The energy management students have taken leading role in making this a success. We must thank them to inspire, because you have already inspired them by saying so much nice words that we learn from you. And you also shown to us that there is no end to learning, though we know that as long as we live, we should learn. But in practice, that now you are insisting that about the big data and the programming language from transition from Fortran to the present one. So these are all these very nice way that we must learn from you, and we must try to practice in our day-to-day life. And that is a big inspiration to all the students, to all the participants, to whom we are also thankful for being present to participate, and they will also receive the participation certificate after filling up the feedback form at the end. And we would request them to organizer to put the link of filling up the feedback form. And I would also thank the AEUSA for providing this platform, Zoom platform, which have been very fruitfully utilized. for this great program. So if I have missed anybody to thank, I am sorry for that. I would like to thank everybody concerned to make this a success. And we wish that this effort will continue and such success will continue in future.
So with this, we come to the end of the CE session, and the participants are requested to note the link of the feedback form given in the chat box. And participants will also be receiving the e-certificates after they submit the feedback form. And thank you everyone for joining for the today's event.
Thank you. So we are ending the session. Also like to thank Dr. Banerjee for so nicely presenting and spending the time and accepting my invitation, though it was within her took the time. Came for a so on the weekend also he came for our talk. Thank you, sir. Thank you. Thank you very much. Sanjana, please end the session.
Yes, ma'am. Okay.